Hello, welcome back to my channel Indianseabeast. Hello guys, how are you? So today in this lecture I am going to discuss so many electrical questions are asked in oral examination. I will just discuss all the questions, whatever the questions I already prepared in my previous examinations. So I will just discuss that is the very important questions. So if the question need detailed explanation, I will give you the detailed explanation, but thoroughly I will give all the overview of the questions. And this is the most important questions already asked in the MMDs, already asked in the oral examination in all India. So don't waste the time, just start the video. For my first question is this, one question is asked by the surveyor, that is the type of governor in auxiliary engines. So what are the types of the governor we are using in the generator? There are the various types. The first type is the mechanical governor we are using generally, that is the centrifugal governor. Use centrifugal force to control the fuel flow based on the engine speed. So what they are using, they use the centrifugal force to control the fuel. Okay, that is the mechanical governor. And we are using the hydraulic governor also. What hydraulic governor, how they control the hydraulic governor, basically with the help of hydraulic fluid to adjust the fuel supply based on the speed changes. Okay, so you don't have to explain this in details, you just they are asking what are the types of the governors. Okay, so first is the mechanical governor, hydraulic governor and electronic governor. If you want to know about in detail, you can go through it. I will explain the governor in the separate video because that is the very lengthy process how the governor is working. I will show you one by one. So now you can just understand mechanical governor, hydraulic governor, electronic governor, and that is controlled by the PID controllers, and digital governors is also there, and one is the speed droop governor is there. Okay, so these are the types of governor. And one question is asked, what is the droop? Okay, so I already explained in my the first lecture video, okay, what is droop. Whenever you start the generator, that time the load will increase, and when the load will increase, speed of the generator will decrease. Load will increase on the generator, then speed will decrease. And what happen, as the load on the engine increases, the fuel supply to the engine is increased, because that time speed will decrease. So to compensate this, we have to increase the fuel supply. So who increase the fuel supply? Basically governor increase the fuel supply. Whenever there is a increase in load, then due to this the speed will decrease and we have to increase the fuel supply. And same as whenever the load is decreased, then speed will increase, then fuel will adjust, fuel will have to decrease, and this is done by the governor. So what is droop? You will say like this, it is a no load speed to full load speed and divide by no load speed. Basically it is a percentage. Okay, so you just read here, as the load on the engine increases, the fuel supply to the engine is increased and yet to allowed to run a proportionally lower speed. Okay, this feature of the governing system is termed as droop. Okay, when more than one prime movers are connected to the same shaft, as in case of generating electrical power, droop permits a stable division. This I will explain you further. I will explain in the detail what is actually happen here. As the load on the generator is increased, so you tell this definition, as the load on the generator is increased from no load to full load, the actual speed of engine tends to decrease. I already explained that as the load will increase from no load to full load, the speed will decrease, and to increase power output in this mode, the prime mover speed reference is increased, and hence the flow of working condition fuel to the prime mover is increased. So I already explained, load increase, speed decrease, and we have to increase the fuel supply. Okay, and droop is basically measured as a percentage according to the formula. It is a variation from the no load speed to full load speed divided by the no load speed. That is the basically our droop. And one more question, what is the deadband? Okay, so surveyor will ask about what is the deadband. Deadband is a band where there is a no changes. I just where the governor does not operate, basically the band in which the governor does not operate at all. Okay, this is the deadband actually. You can see here. The deadband of a governor gives the range of speed after which the governor start operating to make the corrective adjustment. It means there is a band difference from here to here, there is a band, so governor will not operate in between this band, it will operate after that is okay. Within this range the governor does not operate at all, and the width of the deadband is inversely proportional to the sensitivity of the governor. It means the more sensitivity, if there is more and more sensitivity, and then deadband is inversely proportional. Okay. And next question is, what is hunting? Okay, so you can tell like this: hunting basically the fluctuation of engine speed. Okay, the main hunting is the continuous fluctuation of the engine speed around the mean required speed is known as hunting. Okay, whatever the mean requirement speed of our generator, whatever the mean speed, actual speed requirement, and let's suppose you need 900 rpm speed from generator, this is your mean speed. Okay, and if there is any variation from this mean speed, up and down, plus minus, up and down, the continuous speed changes is there, engine speed, that is known as the hunting basically. Okay, this happens when the governor what are the reasons? Basically this happens when the governor is too sensitive. It means the governor sense with a very small changes, governor starts sensing. Okay, and changes the fuel supply. If there is a continuous changes in fuel supply, then also governor will sense and increase or decrease the fuel supply, and due to this the hunting will occur. Okay, with a small change in the engine rpm also, let's suppose the engine rpm is 900 rpm, so, and suddenly it fall down to 890, 920 rpm, there is small changes, but due to these small changes governor will act and increase or decrease the fuel supply, and due to this the hunting will occur. So basically this is the hunting, you can tell like this. Now come to the next question: AC and DC motor construction. What is the AC and DC motor? You know this AC motor construction, how it's look like. I will just show you in little brief how it's look like. I have photo, maybe I will show you. Wait, this is the AC motor construction. Okay, so you see this is the AC motor construction where we are giving this three-phase supply. Here we will give three-phase supply. Okay, and you see this is the stator winding. Okay, this is the stator winding, where the winding is done on the stator side. Basically from here we are giving the power. In the stator winding we are giving the three-phase supply, and this is the rotor which is rotating and produce the mechanical energy. This is the rotor which is rotating and produce the mechanical energy. From where is the mechanical energy is produced? Okay, mechanical energy is produced and we are getting the power. So this is connected to any other pump for taking the mechanical power and convert into the various another power. Okay, so this is the rotor, this is the stator, this is the cooling fan which is mounted on the rotor circuit, and this is the bearing, this is the bearing. Okay, this is the bearing which provide the friction. Okay, this is the rotor, and this is the total overall frame is there, and this is the end cover. Okay, you can understand it very well. And this is the terminal where we connect the three-phase supply. Okay, and here this is the AC induction motor. So there is a rotor which is made up of laminated steel, and conductor bars is there and short circuited via the end rings, so that the current will flow in a continuous loop. Okay, so if current is flow in a continuous loop, it will induce current is there, and due to this induced current the EMF will induced and torque will generate. I will explain everything in detail. This is my another lecture, I will explain you in the detail. So just you they are asking about the construction. So you see this is the stator winding, this is the rotor and all this, and this is the shaft. Okay, and this is the bearings. Okay, and this is this is driving end bearing, and this is non-driving end. They are the two bearing in the motor. You can just remember, this is the driving end where we drive, and this is the non-driving end. Okay, and some are have to put the grease, big motor have to put the greasing, and small motor don't need greasing. Okay, they are having air circulation, cooling is there. Okay, and this is the rotor, and this is the total frame. Okay, So these are basically the construction, and there are the different motors. Like in DC motor, rotor side we do the armature windings. Okay, there is some armature winding. We are not putting this conductor bars, where we are doing the same winding like this in the rotor circuit also. And there are the various motors also. I will explain you in next detail. So okay, so here I write like this also. You just read here. AC motor construction, stator, which is the stationary part of the motor which not rotate, and houses of coil, it wind with the houses of coil. When AC voltage is applied to the coils, a rotating magnetic field is created. Okay, how the motor is working, I will explain you each and everything. Just here they ask about the construction, so I will not explain about the working. I will just explain about the construction. There is a stator, which is a stationary part. There is a rotor, which is rotating part made up of laminated steel with a conductor bars of a copper. Okay, and there is a air gap between stator and rotor. Like this is rotor, this is stator, and there is air gap. Okay, air gap, like 2 mm air gap is there. It must be, air gap must be there. If there is no air gap, there will maybe short circuit between the stator and the rotor. So air gap is must needed to, and if you increase the air gap also, then also problem will happen, because the flux will not link with the rotor circuit properly, and so that torque will not produce properly and it will not rotate. So you remember this one also. And housing bearing I already show you. Instant and fan I also showed you. Show you. And type of AC motors, there is another type, like induction motor is there, synchronous motor is there. Induction motor rotor rotate with the help of rotating magnetic field, but in synchronous motor there is no relative motion between the relative rotating magnetic field. We are providing the external DC source. We are providing the external DC source for the rotor magnetic circuit. Okay, so you understand this. I will explain in detail about the synchronous motor and its induction motor principles. Now I will not explain about the working. Now they ask about the DC motor construction. This is also one question. Kisarware will ask about what is the DC motor and how DC motor construction is. So here they ask about the construction, not the working. So I will explain. Here also a stator is there, and here also rotor will be there, but here one difference is there. There is a commutator. What is the use of the commutator? I will show you what is the use. But here also a stator which provide a stationary magnetic field for the rotor to rotate. Okay, they provide the rotating magnetic field. How they provide the rotating magnetic field? Because when we give three-phase supply and the coils are wound in such a way that there is a 120-degree phase difference is there, and due to this phase difference a rotating magnetic field will create. So for this magnetic field they provide for the rotor to rotate this. Okay, and rotor also rotating part of the motor wound with the coils of wire. In DC motor I will tell you there is no conductor bars or short circuited end rings is there. There is a wound of coil, same as a stator. How we did the windings in the stator, we did the same type of winding in the rotor also, and that is called as the auxiliary armature winding. Okay, here we will call armature winding, and we will give supply, external supply to the armature winding also sometime. And when current flows through this coil, when this current flow through this coil, they interact with the magnetic field to the stator. When we give supply to the DC field, let's suppose we give DC field to this armature winding of the rotor, then the current will flow from it, current will flow, and due to this current they produce a magnetic field, and when this magnetic field interact with the stator magnetic field, due to this torque will produce and it will rotate. So I will explain about later. Commutator, what is a commutator? Commutator, the main purpose is to reverse the direction. It is like a switch. Okay, you just tell it is like a switch where they convert AC into DC also. The main purpose is to convert AC current into DC. Okay, AC current into DC, where they convert the AC current into DC, and the main purpose of this, they reverse the direction of current through the armature winding. Okay, the main purpose, they reverse the direction. Why they reverse the direction? Why the need of the reverse of the direction? I will just explain you after a bit. So the main purpose is the commutator. It acts as a switch. You can write like this: it act as a switch, and it reverse the direction. It reverse the direction and also act as a rectifier because it convert AC into DC. Okay, so I will explain you later. And there are the brushes. The main purpose of the brushes, it's look like a carbon graphite brushes. You see in very so many places you can see in the vessel there is a carbon brushes which is footed just mounted on the shaft, rotor shaft, because it will not rotate. It will just supply the flow of current to the rotor circuit. It will not move. It will just fix on a rotor shaft. A rotor will rotate and it will just make the continuity and current flow between the rotor circuit. Okay, usually made of the carbon brushes, maintain electrical contact with the rotating commutator. It's just mounted on the commutator which is fixed on a shaft. Okay, I will just show you. Enabling current flow to in the armature winding. What is the main purpose? The current which is flowing to the armature winding of a rotor. So how the current is flowing? With the help of brush, and brush giving supply to the current to the commutator, and commutator via it's going to the rotor circuit. Okay, so I will just show you. And there is a frame and bearing. I already just saw on the AC motor there is a bearing, non-driving and driving ends. So what are the types of the DC motor? There is a brush type DC motor and brushless type DC motor, and there are another type also. Matlab inside there is another type, that shunt, series and compound DC motor. I will explain you about this in also later section. Compound DC motor. These are the also motors are there. Shunt, why we are using shunt, why we are using series, where we are using in cranes we are using series motor for high torque. Okay, and there is a compound which a combination of series and shunt. I will show you. You can just tell also like this: shunt, where there is a shunt DC motor, series DC motor. In shunt, shunt is there, series is there, and compound is there. Compound in which series and shunt winding is there. Okay, so basically these are the thing. AC motor I already explained you how AC motor will work. I will explain in the next sector. Now just the surveyor asked about the DC generator, how the DC generator voltage is produced. So let's suppose this is a coil which is rotating in a magnetic field where there is a two permanent magnet which is north pole and south pole, and this is the rotating coil which is rotating. Okay, this is the rotating coil, and this is the slip ring. Okay, this is the slip ring, and this is the carbon brushes. Okay, slip ring basically uses for the adding external resistance. Also in sometime in motor we are using the external resistance to increase the torque behavior, so we are using the slip rings, just like a ring type. This is a slip ring, so we are using a slip ring in a AC generator sometime, and in the DC generator we are using the commutator. We are not using the slip ring. Why we are not using? Just I will explain you. You just see. This is the north pole and this is the south pole of the permanent magnet, and here is the coil. And what will happen? Let's suppose when we give the supply, for the negative half and positive half. For the positive half, let's suppose for the positive half, what will happen? The current will start flowing because this is the magnetic field here, and the current which is perpendicular to the magnetic field, then there is a force will act. Okay, according to the Lorentz force, if you see the Lorentz force, whenever the current carrying wire having the placed in a magnetic field, it will always experience a force. Okay, and force will experience only when there is an angle between current and magnetic field. Okay, so there will be force will act. So for positive half cycle, because the field direction is here and current direction is here, so there is a difference, 90-degree difference. Some difference is there between current and field, so there will be force will happen and it will turn from here to here. So A and B, this position will turn after half cycle to this position, and this position will come here. Okay, So for positive half cycle the current will flow like this, okay, current will flow like this, okay. For positive cycle current will flow how? G H A B C D E F, like this, G H A B C D E F, okay. So current will flow towards the load, from here to towards the load. Now let's see the negative cycle. What will happen if you give the negative cycle? Now the direction will reverse. You see here direction, previously our A and B is here, now A and B will go this side, okay. So now our A and B will come here and C and D will come here. Now for negative half cycle the current direction is here and here, this is the current will flow from here. Now you will see current will flow from this side, from here the current will flow from A H G, okay. Current will flow, you see current will flow from A H G, from this side. So what will happen? Current direction also changes and now we are getting negative cycle, okay. So for AC generator it's okay, it's generating AC voltage, okay, it's generating AC voltage. But for DC generator we want DC, we not want this negative cycle. So what we have to do? We have to just reverse this negative cycle into the positive cycle, because we need DC output, not a AC output. So how we can reverse this direction? We can reverse this direction with the help of commutator. So what will happen? It just reverse the direction in every half next cycle, so that it will always rotate. This rotor will always rotate and torque will maintain, and we will get a DC voltage, okay. So now you understand what is the commutator. I will just explain you what is the commutator, okay. With the help of commutator we are getting DC voltage, so okay, with the help of commutator we are getting the DC voltage from DC generator. Otherwise we will not get DC, we will get AC at the output, even giving DC. Even if we are giving the DC voltage, we are getting AC, we are not getting DC, because there is no commutator. If you put the commutator, you see this is the commutator, we will put the commutator. What will happen here? For every cycle this commutator will rotate, because this commutator will rotate and everything will be fixed. So current direction will always like this, there is no change in the current direction, so we will get always DC. So this is the use of the commutator. You see here the carbon brushes, and this is the commutator where the carbon brushes is fixed on the commutator, and this is the shaft, okay, and we will get like this. So I explained this one. So difference between AC and DC motor, now you can easily explain. AC motor, there is a rotor, there is a main shaft, okay, and this is the armature winding, this is a cooling fan, okay, and this is the end bearings is there, non-driving and driving ends. But in the DC motor you will see there is armature winding. I told you before, there is armature winding in the DC. You see, not a conductor bars is there, there is armature winding, and here is a skew symmetric rotor is there, okay, and here is the armature winding is there. And this is the commutator. You see there is stripes, there is a copper stripes is there. This is the commutator basically, and here the carbon brushes are fitted on the top of the commutator, and commutator fitted on the shaft of the rotor, okay. And there is a air gap between there. This is the armature, this is the armature, this is the shaft. Armature winding is there for the stator. So this is the basically whole construction of DC and AC motor, okay. So now you can understand with, but I will just give you the little explanation. If surveyor, let's suppose, ask you how the DC motor will produce voltage and AC motor will produce a voltage. So what will happen here? You give three-phase supply to the stator, you give three-phase supply, and these coils are 120 degree to each other, so they produce a rotating magnetic field. So there will be rotating magnetic field will there, and this rotating magnetic field, when it's cut to the rotor circuit, because when it's this magnetic field cut this rotor circuit, due to this what will happen? Due to this another magnetic field will produce, because these are end circuited, these are short circuited by the end rings, and whenever the current carrying wire, current carrying conductor plays in a magnetic field, it always there will be induced EMF will be there. Electromagnetic induction principle, if you know, whenever the current carrying wire plays in a magnetic field, it always EMF will be induced. So here, when rotating magnetic field cut this rotor circuit, okay, cut this rotor circuit, so rotating magnetic field will produce, and when these first of all I will explain easily. This three phase supply will given, rotating magnetic field produce, and this rotating magnetic field cut this rotor conductor, then EMF will induced, and due to this EMF a current is induced in this circuit, and due to this current a magnetic field will produce. Okay, due to this current a magnetic field will produce, because a conductor, if there is a current is flowing, then nearby the magnetic field will produce. Okay, so secondary magnetic field, how it will produce? Simple language, when we give supply, three phase supply, this interact with the rotor circuit, due to this EMF will induce, and due to this EMF will induce, then induce current, and this current induce secondary magnetic field, and when this secondary magnetic field interact with stator magnetic rotating magnetic field, then due to this relative motion between stator magnetic field and rotor magnetic field, okay, and due to this a torque will produce, and this torque will start rotating the motor. In a simple language I will show you here. Okay, just I will show you. Wait, what will happen? Stator three phase supply will given, rotating magnetic field will produce in stator, rotating magnetic field cuts rotor conductor bar, end rings are short circuited by end ring, EMF will induce current, and then magnetic field produced by the rotor, and that is the secondary magnetic field. And this secondary magnetic field interact with the rotor magnetic field of the stator, and due to this torque will produce and start rotating. That is the working. Okay, but in the DC motor what will happen? DC supply stator field poles also, we are telling this field poles also sometimes, okay, and field windings also. Okay, so what will happen? We will give this three phase supply to the field poles or field winding, whatever you tell. The constant magnetic field generate, because we are giving the DC, we are giving the DC. Okay, supply current to the rotor armature winding. Okay, when we give external supply to the rotor armature winding. Okay, here we are giving three phase supply to the stator and external DC supply to the armature winding, and when with the help of engine, when we start rotating, due to this a rotating magnetic field will create at the armature side, and when it interact with the constant magnetic field by the generator, there will also relative motion between this stator and stator magnetic field and armature magnetic field, and due to this torque will start produce. So I will just give you the simple explanation in very short. I will explain you in detail also, but I have to discuss so many questions, so I just give you the simple brief. Okay, so what will happen here? Constant magnetic field will given, supply current to the rotor and armature winding, current carrying auxiliary winding placed in a magnetic field, EMF will induce, current induce, and due to this relative motion, when it interact with the stator magnetic field, then torque will produce. Okay, then you can understand current carrying. Okay, commutator, with the help they reverse the direction, because the commutator is there, they just reverse the direction in every half cycle, so that it start rotating in a same motion, same direction, and there is no variation, and we will get DC supply. Okay, so AC motor I already explained how it's working. It's very simple. I already explained, you just read this also, no need how torque is produced, because rotor current is there and stator flux will be there, and due to this we are getting a torque, because torque formula is phi IR cos phi, where IR is the rotor current, and phi is the magnetic flux by the stator, so due to this torque will produce. Okay, so I just explain you, and how the force is produced. For better explanation, when a current carrying conductor placed in a magnetic field, it always experience a force, but the angle should not be 0 degree. If they are parallel in the magnetic field direction, there is no force will produce, and force will 0, so torque will also 0. So it always perpendicular and within some angle. They need some angle, at least some angle is there, not 0 angle. So our torque will be there and force will be there. And what is the difference between Fleming left hand rule, right hand rule? So somebody will ask how you can know the force direction and all. So there are Fleming left hand rule and right hand rule is there for knowing the force direction. So Fleming left hand rule, basically we are using electric motor, and Fleming right hand rule we are using an electric generator. And the purpose of this rule is to find the direction of magnetic force acting in an electric motor. The main purpose is to find the direction of magnetic force. And for Fleming right hand rule, the purpose of the rule is to find the direction of the induced current in electric generator. Okay, so here middle finger represent the direction of current, and here middle finger represent the direction of induced current. So this is the, you see, this is the our thumb, here is the thumb, here is our hand, where this here is the force or motion, here is the magnetic field, and this is 90 degree, this our middle finger is 90 degree current. So here this is the Fleming left hand rule, there is the right hand rule. Okay, I explain it here. Here is the current direction, this face of this hand outward, this is the magnetic field direction. Okay, and the finger is the magnetic field direction, thumb is the your current direction, and the face of our hand is the force direction. Okay, so this is the, you can calculate like this. Now I already explained how the rotor material is made up of. Rotor material basically made up of laminated silicon steel. Okay, why we are using laminated one? Because to minimize the eddy current loss. How the eddy current is produced, I already explained in the lecture 1, you can go through there. Okay, so rotor winding types, there are the various winding types is there. Squirrel cage rotor, basically induction motor, wound type motor, slip ring motor. Okay, there are the various types of induction motor also, double cage rotor, wound type, slip ring induction motor, squirrel cage rotor. So I will explain you everything one by one. So here no question is there, so I will just move next question. Why distilled water is added to the battery? The next question may be asked by the surveyor, why distilled water is added to the battery. The main purpose of the distilled water is very simple, to maintain the electrolytic level. Electrolyte balance is there, because at the time of discharging, because when the load is connected, that time current will be discharged more and more. So that time if the current is drawing from the battery, then due to the chemical reaction, because inside sulfuric acid and water is the electrolyte in the lead acid battery, and for alkaline battery there is nickel hydrate, and for alkaline NiOH4 nickel hydrate. Okay, nickel hydrate. Okay, nickel hydrate plus KOH, potassium hydroxide. These are the electrolyte. And for alkaline, the specific gravity does not change, but lead acid specific gravity will change. Okay, so I will explain you further. So electrolyte in the lead acid battery is the sulfuric acid and hydrogen. So at the time of the discharging, due to the chemical reaction, more and more diluted water. So what will happen? More and more diluted with the water, because at the time of discharging, this sulfuric acid concentration will fall down, and water concentration will increase and more diluted with the hydrogen. Okay, so what will happen? Distilled water is added to the lead acid battery to maintain the electrolytic balance. So we have to maintain the electrolytic balance H2 and H2SO4, because the sulfuric acid is it is basically in lead acid battery 1:3 ratio are inside the your lead acid battery. Okay, this is the ratio 1:3. One is the sulfuric acid and 3 is the water. So we have to maintain this sulfuric acid concentration, otherwise the corrosion and this metal will exposed in the air, and that's why the oxidation will happen and leads to the corrosion. And another thing I will show you. So lead acid battery, to maintain electrolyte balance in this battery, the electrolyte is a mixture of sulfuric acid and water. What will happen? Electrolyte is a mixture of sulfuric acid and water, and during battery operation water evaporates or can break down due to the electrolysis. Okay, particularly during the charging. What happens in the charging? This hydrogen gas and water evaporates. So that this concentration will fall down, and due to this the what will happen? This lead to the decrease in water level. So water level will decrease because more and more H and hydrogen gas and water will evaporate at the time of charging. So concentration will decrease, and due to this water level will also decrease, which expose the battery plate. What will happen? Then they expose the battery plate and reduce the battery efficiency. So you can tell like this: adding distilled water keep the electrolyte level optimal. So if you add the distilled water, why we are adding the distilled water? Because this is not contain any mineral impurities is there. There is no impurity inside the distilled water, because the minerals and impurities are not good for the battery, because due to this the corrosion, chances of the corrosion will happen, and there is a not proper electrolyte reaction will be there. So adding distilled water keep the electrolyte level optimal, ensuring proper chemical reaction for charging and discharging. Distilled water is used specifically because it is a free of mineral. I already told you it's free of mineral and impurity that could react with the battery components, potentially causing build-up, reducing efficiency. Because if there is a mineral, so our battery life will reduce, and there potentially causing build-up, and there may be resistance will increase at the terminal of the battery. Corrosion chances will increase due to the impurity and minerals. Okay, so these are the things. Next question: ICCP components except anode and cathode. So you know the ICCP, we are basically using the ICCP to protect the ship hull. Basically, why we are using the ICCP? To protect the ship hull. And ship hull, how we are doing? Because whenever the two dissimilar metal, let's suppose two dissimilar metal come in a contact of electrolytic medium, then what will happen? The more active metal will undergo corrosion and act as an anode, and the least active metal will not undergo corrosion and act as a cathode. But due to this two dissimilar metal, there is a potential difference is created between anode and cathode. It means the less active material and more active material, because they are two different dissimilar metals, and due to this potential difference is created between them, and due to this potential difference a corrosional current will increase, and this corrosional current will corrode the ship hull. Let's suppose the ship hull is which is more active metal. So if you not protect this ship hull will corrode, because it will lose electron day by day. Corrosion will take place because it will act as an anode, and due to the galvanic cell it will act as an anode, and more metal will corrode and decompose very fast, and after that ship will sink. So we have to protect our hull. Anyhow we have to protect, but how we are protecting? We have to minimize this corrosional current, which is basically created by the potential difference of between anode and cathode potential difference. So what we are doing is, with the ICCP, we just impart, with the help of control panel, PCB and thyristor control circuit is there, they just measure the potential difference between the ship hull and a reference anode. We are taking a reference anode, just measure the potential difference between the ship hull and reference anode, and they send the current which is greater than this corrosional current in opposite or same direction. Okay, corrosional current, so that it will minimize the effect of this corrosional current, and this ship hull will act as a cathode, not as a anode. So our hull will protect. So this is the function of ICCP. I will explain you and show you everything later. So what are the other components? There is a rectifier also, which what will happen? They just convert AC into direct DC to power the ICCP system, because ICCP system is working on DC system. So DC power. So we use rectifier circuit, reference electrode also we are using, and there is a control panel which basically measure the potential difference between the strip hull and reference anode, and send a corrosional current which is greater than our main corrosional current, so that our corrosional current effect will be minimized. So control panel is there, inside the PCB, and thyristor circuit is there for controlling the and measuring the current basically, and cable and connection is there. So what are the components? You already know what are the external components. And next question is, what is vacuum diode? Okay, what is vacuum diode? So vacuum diode is just like nowadays we are using semiconductor. Okay, what we are using nowadays, semiconductor is very small and it can basically control the flow of current from in a circuit. So previously we are using the vacuum diode, because that time no semiconductor is there. We are using is vacuum diode is there. There is a anode plate and cathode plate, and there is a seal chamber. Okay, this is a glass seal chamber, and when we give supply positive to the anode and negative to the cathode, then what will happen? The cathode emits electron through a process of thermionic emission. There is a thermionic emission, because due to the increase in current, the temperature here increases, and it will, when the work function of this electron is greater than this temperature, because the temperature increasing, this work function of this electron will get energy and excite from cathode and move toward the anode. Okay, move toward the anode. So what will happen? Here electron will travel from cathode to anode, and then current will flow from anode to cathode. So there will be flow of current here. Okay, there will be flow of current. And semiconductor also, what we are doing, with the help of base current, we just start flowing the current from emitter to collector to emitter, and their electron flow between the emitter to collector. Here also same like this. Okay, here also same, we just give the supply, the electron start emitting from the cathode towards anode, and due to this current direction will always in opposite of the electron flow. So current will start flowing from anode to cathode. So you already know about the vacuum. It is a simple electronic device that allow current to flow in a one direction, similar to semiconductor device. So you understand vacuum diode. Okay, whenever positive voltage is applied to the anode relative to the cathode, the electron emitted from cathode are attracted to anode, resulting in current flow. Okay, understand? So governor hunting I already done before above. Now what are the ACB traps? Okay, what are the ACB traps? It means there is a various protection in the ACB. ACB is the air circuit breaker. How the ACB is working, I will tell you before after that, because there is a two main contact, and one is the arcing contact, and how they are working and which contact will make first and which contact will disconnect first. I will tell you each and everything in detail. So now just see the trips. What are the ACB trips is there? Okay. So ACB trip, there is overload trip is there. Okay, overload trip is there in ACB. Overload trip is there. You can read this for mechanism, how the overload trip is working. Basically there is a biometallic strip is there, and according to the temperature it will bend and trip the circuit. And what is short circuit trip is there? There is short circuit trip. It means when the when there is a when let's suppose two conductor is there, when they touch each other, and due to this what will happen, there the voltage will become zero and there will be short circuit. Okay, and high current will start flowing and high current surge will be there, because now the potential difference becomes zero. Okay, So short circuit trip is there, ground fault trip in the ACB. Ground fault basically protect us from the ground fault where current intentionally unintentionally flow to the ground. It means some wire touching to the ground, then current start flowing from the circuit to the ground because of the low resistance path. So it will protect from this fault also. If like this situation happen, it will trip the circuit and protect the generator or load. Okay. Instantaneous trip, when there is a sudden short circuit will happen. Let's suppose two wire running wire current flow will be there, and then when they touch each other, then due to this short circuit will happen. So there will be instantaneous trip also given. There is an instantaneous trip. Overcurrent trip is there, but there are overcurrent trip. Overcurrent, there is long range delay trip. Long range delay trip is there, delay trip, and short range is there, and instantaneous also is there. Instantaneous also. Instantaneous when will happen? When your full load current is greater than 1000 ampere. Okay, greater than 1000% of full load current. Okay, whatever your full load current of the equipment, when the current exceeds greater than 1000, it will trip instantaneously within a second, within a 0.1 second. No delay is there. Okay, and short circuit when the full load current is 200 to 600% of full load current, then due to this the short range trip will happen and it will trip the circuit within 0.2 second to 2 second. Okay, and long range trip when the full load current is what will happen? Your full load current is greater than 125% of full load current, then it will trip into 2 to 20 second. Okay, so this is the basically trip is there. So you understand. So what are the trips? Overload trips is there. Okay, 105 to 120 long range trip. Short circuit trip, short range trip is there. Okay, short circuit trip is there. Under voltage trip is there. Over voltage trip, earth fault, and sun trip is there. Sun trip basically we are using to trip the circuit from a remote location, from the external signal. Okay, from the external signal. Okay, so you understand this. I already explained. Now I will go further.